Assalamu alaikum beautiful people. I hope everybody will be fine. Today in this video lecture, I will guide you for some of important technical terms in RCC Slab. Actually, we have a lot of technical terms, but I am trying to discuss some of them. Actually, as you know, a lot of students, some of students completed BTech, some of diploma, and they are working on construction site to get some experience, site experience. So they wasted a lot of time there, but they don't know the technical terms, they don't know how to read civil engineering drawing, about RCC work. So therefore this video can help you. So therefore watch this video till the end to know something new about steel structure design and RCC slab. Let's get started, guys. Remember, for example, I have a slab, this one, which length is, suppose, 30 feet, and its width is 16 feet. First of all, you should have knowledge about in steel structural design what is main bar and what is distribution bar and its details. Okay, remember guys, a steel reinforcement which we provide on lengthwise, same as you can see, this is its length and this is its width. When we provide in lengthwise, same like this, so these steel rods are called what? Main bars. Okay, and steel reinforcement which we placed on widthwise like this, as you can see, the width is 16 feet. So these steel rods are called these what? Distribution bars. Okay, now let me discuss its detail. Okay, for main bars, okay, so this is main bar, so it means the main bar's dia should be maximum. Try to use maximum dia compared to distribution bars. How? Suppose if we are using main bar dia 12 mm main bar, okay, so the distribution bar dia should be 10 millimeter. Right, distribution bar dia, this one. But it's not important that if you want to use the same dia for distribution bars and main bars 12 millimeter, it's also okay. Okay, but the main bars dia should be maximum if you want to get good result from steel reinforcement or from the slab. Okay, the next one, guys, remember, normally for residential building, so the first term is about steel reinforcement. The first one is about dia of steel. Okay, now the second one is about its spacing. Right, as I told you before, dia of steel for the main bars should be 12 mm and the distribution bar should be 10 mm. Okay, now guys, the other one is spacing. So if you want to increase the spacing, means sometime at the rate like this, 6 inches C/C. So C/C means center to center distance between two steel rods. Okay, so for main bars, spacing should be minimum compared to distribution bar. First of all, if you want to use 10 mm at the rate 6 inches C/C for distribution bars, so it's okay. But if you want to use the minimum steel reinforcement, so in that case you need to use minimum space. So the minimum space should be placed for the distribution bar, not for main bar. Okay, for example, if you want to increase the spacing in steel reinforcement for slab, So you try to increase the length of distribution bars, the spacing of distribution bars. So you can say that 6 inches, 7 to 8 inches you can also keep, 7 to 8 inches. If you want to increase the spacing, so you should not increase the main bar spacing, but increase the distribution bar spacing. One thing other guys, so this is the spacing, okay. Now the third one is for placing. This is also very important. Remember, in RCC slab, the main bars should be placed at the bottom. The main bars first should be placed, the main bar, this one, which is 16 feet, okay. Then above this steel bar, okay, you should place the distribution bars. So therefore, why it's called main bar? Because it placed before the distribution bars, okay. Then you can provide, so this bar is distribution bar and this one is main bar. So therefore I am telling you the main bar dia should be maximum, try to use maximum compared to distribution bar. If you are using the same dia for main bars and distribution bars, so it's also better for you people, okay. Now this is the spacing which I have discussed the front of you. Now guys, in RCC slab, as you know, we are using the hidden beam or concealed beam. What is hidden beam and concealed beam? Why we are providing concealed beam or hidden beam inside RCC slab? Okay, remember we are providing, in fourth step we are providing hidden beam or concealed beam. Remember, when the length of the span is maximum, the length of the span is maximum and we don't have the column, like here we don't have the column, so in that case, okay, if we have the maximum span, so in that case it can make bending moment at this place, like this, it will make bending moment like this, and also this one will make bending moment same like this. So you will face the problem, so the structure will face the problem here. So therefore, to avoid the bending moment at the mid, because we don't have the support here and we have the maximum space, so in that case we should provide the hidden beam. Remember guys, the hidden beam depth, okay, so the hidden beam depth should be same the depth of the slab. For example, this is hidden beam, okay, and this is RCC slab. If the thickness of the slab is, for example, if this is 6 inches, this is very important. If the thickness of the slab is 6 inches, so the hidden beam thickness should also important to provide 6 inches. It should be also 6 inches, right? This is the depth of hidden beam, and why we are providing for maximum space. Especially this hidden beam we can provide in TV lounge, living room, where we have the maximum space, right? The other point, inside steel reinforcement which we are using for hidden beam. So the hidden beam steel reinforcement should not be less than, the dia should not be less than 12 millimeter. Remember this point, with the spacing of 4 inches. Also we are providing the stirrups inside hidden beam, okay, so it should be placed with 4 inches, not more than 4 inches, okay, because otherwise again it can provide the bending moment inside the building, okay. So as you can see, this is hidden beam, okay. Now guys, try to use in hidden beam at the bottom, try to use 4 steel rods, and the top if you want to use 2 steel rods, so no problem, okay. But also you can decrease the dia of top bars. If you can also use 10 millimeter. In the case of if the bottom steel rods, if we are using 12 millimeter, so the top should be 10 millimeter, no problem. If you are using the same, so no problem. But if you are using 16 mm for tension zone, so here in that case this dia should be increased up to 12 mm, like this. These things are directly proportional. If the bottom bar's dia is maximum, for example 16, so the other should be 12. If this is 12, so the other one should be 10, like this. because as I told you in many videos that concrete is strong in compression but it's weak in tension. So we should try to use maximum steel reinforcement for bottom portion, for tension zone. Okay. Now guys, this is the sum of details for the hidden beam. Now I will discuss its lapping. Okay. As you can see guys, sometimes we are providing the lapping at the mid. As you can see, like one steel rod we are providing the lapping here like this, and sometime here. So the lapping is not allowed at the mid. Okay, again the same thing as I told you, it will make bending moment, the steel will fail inside the slab. So therefore when we overlap one steel rod to another, so it will be weak, not strong. Okay, so in that case we should have knowledge about where is the best place to provide lapping length. Now I will discuss lapping and slab. Okay, the fifth one is lapping and slab. As I told you guys, here, as you know, this is beam, these are beams. Okay, also that one, and here at this places we have the columns. Here we have the column, this is the other column, this is the other one, this is the other one. Okay, so actually you can see right now these are beams, these are. Okay, so these are beams. Now remember guys, the lapping should not be provided at the mid, and also the lapping should not be provided with L/4 distance. So here guys, we should provide the crank bar or bent up bar which is same like this. Like this we are providing lapping, the crank bar or bent up bar. So guys, don't provide the lapping length at the mid, and also don't provide lapping length at these places, because here we have maximum shear stresses at the end of the support. So it can provide the cracks which when we provide the lapping length. So therefore try to use the lapping length not at the mid, not at L/4 distance. So try to provide the lapping length at this place. After L/4 distance you are able to provide lapping length, but not at the mid. So now this is the place, or you can provide at the junction also, where you have the junction. So there you should provide the extra bars. So in the case of extra bars you can provide the lapping length, but this is the best place. For example, if the total width is 16 feet, so when we use the formula which is L/4, so L/4 is this place, L/4, and this is also L/4. So this is 16, so means, so this is 4 feet. Okay, so also this is 4 feet. So don't provide the lapping length at this place and also at this place, but you are able to provide after L/4 distance, but not at the mid. This is also the main important, not at the mid, not at L/4 distance, but after L/4 distance you are able to provide the lapping length here. So this is the best place to provide lapping length, but the lapping length should not be less than, in the case of slab, 50 D, where D is die of steel rod. Okay, so if you are not a technical person, so in that case the lapping length should not be less than 1 meter for normal residential building. Guys, hope this video can help you some technical terms of RCC slab related with steel reinforcement details. Thanks for watching. See you in next video. Goodbye.